Good morning to one and all. My name is Dr. D. Sudhakar, working as Professor and Head of Mechanical Department at Siddhartha Institute of Science and Technology, Puttur. Today, we are going to discuss about the metal casting processes. And this metal casting process is come under the manufacturing process. So, in this unit, we are going to discuss about the metal casting process, introduction to sand casting, sand mold, types of patterns, pattern materials, pattern allowances, mold and sand properties, and testing, core types and applications, molding machines types and applications, melting furnaces, principle of special casting process. And under this one, we're going to discuss about the shell casting, investment casting, ceramic mold casting, pressure die casting, centrifugal casting, carbon dioxide casting process, stir casting, and defects in casting process. Now coming to the introduction of sand casting. First of all, what is meant by casting process? A casting is a manufacturing process used by the forging industry to produce an object of the specific desired shape. Casting means it is the process of manufacturing of any component of desired shape. So under this one, what we're going to do, whatever the shape we want to manufacture or whatever the component you have to manufacture, the same shape of the component, you have to prepare a pattern. By means of that pattern, you have to create a cavity inside the mold. And after removing the pattern, we have to pour the molten metal into that cavity and we will give some time for the solidification. After that, after solidification, we're going to break that mold. Finally, we will take out the casted components. This is the process, what exactly happening in the casting process. And sand casting. Sand casting is a process in which the molten metal is poured into a mold made of sand. Sand casting means here the mold is made from the sand. So it is a temporary molds. Temporary molds. So in this process, the molds are made from the sand. Then in that one, we're going to pour the molten metal and we'll give some time for the solidification. After that one, we're going to break that mold and finally we're going to get the solidified component. So these are the basic components present in the sand casting process. The main components are like the first one is the topmost portion, part is the cope and bottom portion is the drag. And the this shape, this is the blue color shape, this is indicates the cavity and this is the core. Okay. And this is the riser, the rectangular portion is called the riser. And this one is the pouring cup. And this is the sprue, down sprue. And this is the runner. And bottom outside portion is called flask. And this is called as a mound. So this entire the bottom portion, this is the midline or parting line in between the cope portion and drag portion. That is called as a parting line. And this entire cope portion is the cope portion and drag portion is completely filled up by means of this sand. And by placing this mold, and after placing this mold, we're going to pour this. After placing this pattern, so on top of this pattern, we are going to place the sand and rammed properly. And after that, we are going to remove that pattern. Finally, you are going to get a hollow casting cavity. So inside this cavity, we are going to pour the molten metal through this pouring basin, down sprue, and it will be entered into the cavity. So these are the basic components present in the sand casting process. So now coming to the what are the steps involved in the sand casting process. There are 6 steps involved in this sand casting process. The first one is place a pattern in a sand to create a mold. And second one is incorporate the pattern and sand in gating system and remove the pattern. Finally, we are going to get the cavity. Then fill the mold cavity with the molten metal. Then after that one, we'll give some time for the solidification, means allow the metal to cool. Then automatically the molten metal will become the solid component. Then finally, we're going to break away the sand mold and remove the sand casting. So these are the 6 basic steps involved in the sand casting process. So these are the steps. By means of these diagrams or steps, we can easily understand each and every step in the sand casting process. In the sand casting process, first we are going to place this mold plate. Okay, on that one, we're going to place this half pattern, and then on top of this mold plate, we're going to place this flask. Okay, this flask is placed over this first pattern, and then this entire flask is filled up with help of mold in sand and rammed properly. And after that one, we're going to take the another plate. On top of that one, we're going to place the another half of the pattern. Then we're going to place the drag portion of the mold. Then we're going to fill this mold with sufficient quantity of sand, and then we're going to revert it back. Finally, the two halves are prepared. This is the first half, that is the cope, and this is the bottom half, this is the drag, are prepared. So on the top of this drag portion, we're going to place this cope portion. So finally, we're going to get the we're going to assemble this drag mold, and then in the bottom position, and cope portion on top of the portion. And before assembling this drag portion and cope portion, we are going to remove this pattern outside. Finally, you are going to get a mold cavity, a hollow mold cavity, and we'll cut the gating system. Then we are going to pour the molten metal through screw basin, down screw, and then through the runner, in gate, and finally it is going to enter into the mold cavity. We will pour the molten metal until to completely fill this mold cavity. And after that time, we are going to give some time for the solidification. So after that, we are going to break this sand mold. Finally, we are going to get the solidified casting component. So like this, we have to prepare. These are the steps involved in the sand casting process. Now we are going to discuss about the types of pattern. Types of pattern. A pattern means, what is a pattern? Pattern means replica of the desired object. So whatever the component you want to manufacture, the same shape of the component you have to manufacture, and that component is called a pattern. The pattern size may be more or less than that of the actual casting component, but the shape should be same. So in casting, a pattern is a replica of the object. Means whatever the component you have to manufacture, the same type of component we have to prepare. That type of is called the replica of the object to be cast, used to prepare the cavity into which the molten material will be poured during the casting process. So this is the meaning of the pattern. The following are the different types of patterns are used in the casting process. The first one is single piece pattern or solid pattern. Second one is the split pattern. Third one is match plate pattern. Next, cope and drag pattern. Fifth one is gated pattern. Then sixth one is loose piece pattern, sweep pattern, skeleton pattern, segmental pattern, and shell pattern. So these are the different types of patterns are available or using in the casting industry. And these patterns are used in the different conditions and for the different requirements. In the coming slides, we are going to discuss about each and every pattern and their applications and their usages also. And what are the functions of the pattern? The main functions of the pattern is, the first one is, it is to produce the mold cavity of the correct size and shape. So by means of this pattern, we are going to prepare the mold cavity. We are going to prepare the mold cavity of the correct size and shape. Maybe the size may be more or less depending upon the material, depending upon the component, but the same is most of the times it is shape. Now, and these patterns are also used to produce the seeds for pores in the molds, then to establish the parting surfaces and the lines in the mold, and to minimize the defects in casting, and to minimize the cost of the castings. So these are all the functions of the pattern. Now we are going to discuss about the types of pattern. First one is the single piece pattern. The single piece pattern. This pattern is made without joints, means it is a completely single product. There is no separate individual splitting components are not possible. So, without joints and partings or any loose piece pattern, in its construction is called single piece pattern or solid pattern. So these patterns are cheaper because there are no intricate parts. Normally, simple shape components are prepared by means of this single piece pattern or solid patterns. So the molding operation takes more time. Hence, these patterns are limited in production. Next, these solid patterns are generally used for large castings of the simple shape. We already discussed. The simplest type of pattern is the flat back, as shown in the figure in the last diagram. So this is one simplest one. And it may have few or no irregularities, and it may not have any core point also. So it's a very simple one. So the few examples of this casting that are made by breaking this mold pattern are solid tamper, stuffing box. So these are all the best examples of the components which were prepared by this solid piece pattern, like a solid tamper, stuffing box, and glad of the steam engine. Now coming to the split pattern, the name itself indicating that the pattern is divided into two halves, that is split into two patterns. For casting unusual shape of the components, if the shape is normal shapes, regular shapes, then we can go for the solid pattern or single piece pattern. So if the irregular shapes are there, then we are going to use for the split pattern. So these patterns are usually made in two parts. So top portion and back portion. One part will be produced lower half of the mold, and other the upper half. The two parts may or may not be of the same size and shape. So sometimes it may be both lower portion and upper portion may be same, and sometimes it may different also. And these patterns are made in 2 or 3 pieces. If there are 3 pieces, scope, cheek, and drag. So because of many times, the design of casting offers difficulty in molding and withdrawal of the pattern if solid pattern is used. So the main problem with the solid pattern is withdrawal problem. So instead of drawing the entire pattern at a time, if you split those pattern into 2 or 3 pieces, then you can easily remove those parts, and finally we are going to get the very high quality cavity. Finally, we are going to get the very good casted component also. Now coming to the match plate pattern, and these types of patterns is made in 2 pieces. So one piece is mounted on one of the side of the plate, and other piece is on other side. So match plate, the name itself indicating this is the rectangular shape is called the match plate. On top of the match plate, one half, and bottom of the match plate is another half will be provided. This pattern, the plate can only carry a pattern or a group of patterns on its 2 sides in the same way. Means on top and bottom of this match plate, you can provide more number of match these patterns, so that by means of that one at a time you can produce more number of casting components. So this plate is usually made of rectangular. Match plate is normally made of aluminum. So the gate and runner also connected to the plate with help of this. So like this, we are going to connect to this plate. Finally, whatever the molten metal is poured, those molten metal will be poured into these mold cavities properly. These patterns are used where the rapid production of small castings and precise castings occurs on a large scale. So wherever you want to manufacture the components in a large scale and rapid production, where if you want to produce more number of components within the limited time, and where it is precise castings are required, there we are going to use this match plate pattern. Their manufacturing cost is also quite high when comparison to the remaining patterns. Then cope and drag pattern, I already know. When we are going to use this cope and drag pattern, the bottom portion is the drag pattern and the top portion is called the cope pattern. So when the size of the casting is very large, it is very difficult to withdraw, and it is very difficult to move from one place to another place, and it is very heavy to lift. Then in all those cases, we are going to use this cope and drag pattern in order to prepare the components. Next, gated pattern, the name itself indicating here we are going to use one gate. See, this is the gated pattern by me, and these are all the mold cavities. These mold cavities are connected to this gate. This is the runner, and these are all the gates. The smaller, this one, are this is the runner. To this runner, all the gates will be connected. At the end of the gates, these mold cavities will be there. Whenever you pour the molten metal on this runner, automatically these through these gates, the molten metal will go and enter into the mold cavity. In all like that, we can prepare more number of castings or more number of components at a time. So a single runner can be done to feed all the cavities. This is one cavity, second cavity, third, fourth, fifth, sixth, seventh, eighth. Here the 8 cavities are there. So in all these cavities, at a time we are going to pour the molten metal. When you pour the molten metal in this runner, automatically this metal will be go and occupy this cavity. Now coming to the loose piece pattern. So this is the diagram indicates about the loose piece pattern. So this entire, this portion is called loose piece pattern, this side, on this side. And this rectangular portion, this small rectangle is called as a core prints. And this is the sands. So in these types of patterns, some single piece patterns are made to have loose piece in order to enable their easy withdrawal from the mold. And these pieces make an integral part of the pattern while molding. See, these, when you are going to removing this pattern and it leaves this loose pieces, okay, and after that, these loose pieces will be exist there only. First, we are going to remove this entire rammed pattern. Okay, this pattern. And after that, we are going to removing this pattern. Finally, we are going to get some additional shapes on the inside the molds. After the mold, see here, first we are going to place this pattern along with these loose pieces. After ramming properly, then the pattern is withdrawn, leaving the pieces in the sand. So this loose piece and this is the loose piece. And this loose piece will be stay here only. And simply we are going to removing this entire pattern. So these patterns later withdrawn separately through the cavity formed by the pattern as shown in the diagram. Then this sweep pattern, and these sweep patterns are mainly used to produce very large castings. So mainly used for the preparation of large symmetrical castings. In the preparation of large symmetrical castings, we are going to use this sweep pattern. And that too, the pattern also expensive to construction. And this is the skeleton pattern. And these skeleton patterns are also used for whenever the casting is very large and only few members are to be made. And it is not economical, a solid pattern that of the same size. So in that conditions, we are going to use these skeleton patterns. Then the segmental pattern, and these segmental patterns are used to prepare a molds of large spherical castings. Whenever if you want to prepare a large spherical castings, then we are going to use this a segmental pattern. And here, use of the solid pattern, the exact size is avoided. So whatever the size is required, according to that one, we're going to prepare different types of things. In the principle, they work like a sweep pattern. But the difference is that in a segmented pattern is a portion of the solid pattern itself, and the mold is prepared in parts by it. See, this is the axis of this sweep pattern, and this one is the fixed, and this entire portion will be rotated like this. Whenever you are going to rotate this entire portion like that, automatically a cylindrical shapes or bell-shaped pattern will be prepared. Okay. So whenever you want to prepare a large spherical castings, then in that condition only we are going to use this segmental pattern. And shell patterns. And these shell patterns are largely used for drainage fittings and pipe work. So this is the best example of the pipe fittings or the drainage component which are used in normal day-to-day life. Then coming to the pattern materials. So you cannot use or you cannot select the material from the pattern just like that. It's all depending upon the requirements, depending upon the cost, depending upon the uses. Based upon all those things, you have to select a right material for the right patterns. So while selecting the pattern materials, you have to consider some of the components or otherwise some factors affecting the selection of pattern materials. First one is the size and shape of the object to be casted. If the size of the component is very large, and if the size of the shape of the component is a different complicated structure, then some type of material we are going to select. We cannot select all the materials for the large shape components and large size components. And the volume of the production is more, then in that condition, we're going to select a different types of materials. And the surface finish and dimensional accuracy required. So, and the possibility of the design change, the molding method used, the cost of the pattern materials. So these are all the factors which are going to affect the selection of the pattern material. Suppose if the cost of the pattern material is more, then you cannot use the pattern just like that. You have to use very carefully. Like that, depending upon the requirement, we're going to select a different pattern material for the different purposes and different conditions. Like a wooden pattern. So what is the main purpose of this wooden pattern? The wooden pattern is available very cheap. The availability is also available. It's available always. And cost is also less. And lifetime of the wooden pattern is, of course, good but when you comparison to the metal, it will be less. And you can produce any complicated pattern by means of this wood, because the machining is very easily when comparison to the metal shape. And the main problem with this wooden pattern is it is going to absorb the moisture from the atmosphere, so that after some couple of days, its shape may out of shape, it may bulge, or it will whenever you are going to use this wooden pattern with sand, automatically sand abrasion will be takes place. Then what will happen? The outer surface or surface finish of those wooden pattern will be damaged. So these are all, there are some advantages are there and some disadvantages are there. Based upon our requirements, we are going to use the wooden pattern in different conditions. The main wooden pattern materials are like teak wood, mahogany, pine, walnut, deodar. So these are all the different types of woods are used for the preparation of the wooden pattern. So these are all the advantages and disadvantages just now we have discussed. It's inexpensive, easily available, lightweight, easy to shaping. These are all the advantages of the wooden pattern. Then coming to the disadvantages, change its dimension due to absorption of the moisture. So dimensions will be changed due to the by absorbing the moisture from the atmosphere. And it is not suitable for the large scale production. And abrasion occurs on the surfaces. Then one more disadvantage is the not suitable for the large scale production and operation occur on the surface, because we are going to use these patterns, wooden patterns with sand. So automatically sand aberration will come into the picture. And high dimensional tolerance is needed when compared to the metal. This is also one of the disadvantages. And very difficult to give fine details of the surface and low strength. So these are all the disadvantages of the wooden pattern materials. Now coming to the metal patterns. The metal patterns are the more extensively used pattern material due to smooth surface finish. So whenever you use a metal as a pattern material, then we're going to get very smooth surface finish. Means abrasion will be less and life will be more. They are used for the large scale production also. And the most of the metal patterns are made by casting process by using the wooden pattern with double shrinkage allowance. So if you want to prepare a metal patterns, first you have to prepare a wooden pattern, then you have to create a cavity. In that cavity, you have to pour the molten metal and allow some time for the solidification. After that, you have to break that mold, and finally you have to take out the metal patterns. So these metal patterns are again used for the creating the mold cavity, and by removing these metal patterns, we are going to pour the molten metal into the cavity, and we'll give some time for the solidification. Finally, we are going to take out the metal patterns. So these metal patterns can be used for more number of times when comparison to the wooden metal patterns. And we are going to provide the double shrinkage allowance for wooden pattern while preparing these metal patterns. So the main advantage of these metal patterns are, like the metal patterns are more durable. Okay, they will undergo less abrasion while using with the sand. And smooth surface, you are going to get fine surface details can be given to the pattern, and do not deform with the while in storage, and closer dimensional tolerances are possible, and high strength. So these are all the advantages of the metal pattern. Then coming to the disadvantages, the metal patterns are liable to rust. So if you place these metal patterns in the outside atmosphere, it will absorb the moisture and it will undergo rust. Rust will be formed. And as it is a metal and its weight is also more, it seems to be very heavy, and it is difficult to move from one place to the another place. And that is also one more is high cost, and it is hard to modify and repairing the metal patterns when comparison to the wooden patterns. Now coming to this pattern, wax as a pattern material, and this wax pattern is not taken out just like other patterns. So in case of the metal pattern or in case of the wooden pattern, after ramming properly, we are going to taking out these metal patterns and wooden patterns, and finally we are going to create a cavity inside the mold after removing this metal pattern and wooden pattern. But in case of this wooden pattern, it is not like that. Instead of the mold is inverted, instead of removing this wax pattern from the cavity, we are going to heat that. We are going to apply the heat to that mold. Automatically, what will happen? Because of that heat, the wax become converted into solid, into liquid. The molten wax is flow out of the mold. Whenever the mold, this wax, molten wax is coming out from the mold, then automatically the mold cavity will be created inside the mold. So inside that mold, we are going to pour the molten metal, and we will give some time for the solidification. And after that, we are going to break the mold. Finally, we are going to take out the casting components. So this wax pattern is the excellent choice for investment casting. And the most commonly used waxes are beeswax, shellac, paraffin wax, etc. Now coming to this polyurethane foam. And they are very light and it can be easily formed into a desired shape when comparison to the other pattern materials. They are suitable for small quantity of light duty works. If you want to prepare small quantity of components of the light duty works, then we are going to use this polyurethane foam. They have very low ash content if they burned. So they are also used in the full mold casting process in which the pattern is burned inside the mold without withdrawing. So here is without withdrawing. Just we are going to burn. And finally, the mold cavity will be formed. Then the plasters. The pattern is made of gypsum plasters. It is also known as plaster of Paris. And they have high compressive strength. These whatever the components or whatever the patterns are prepared by this plaster of Paris having the high compressive strength. Normally, the plasters or the plaster of Paris will be expand during the solidification. There are different types of gypsum plasters are available. They have different expansion rates, settling time. Advantages are they are cheap and easily workable. Now we're going to discuss about the pattern allowances. So what is meant by allowance? Allowance means we're going to provide the extra dimensions on components or less dimensions of the components in order to compensate the compressive or expansion or compression things. So a pattern is slightly larger. What a pattern is slightly larger version of the casting. So whatever the component you want to manufacture, suppose if you want to manufacture a component or shot put throw ball of 100 mm diameter. So if you want to prepare a shot put throw ball of 100 mm diameter, then you have to prepare a pattern of slightly larger than that of the actual things. Why we are going to prepare a slightly larger? So whatever the larger amount we are going to allowing or providing on 100 mm, that is known as a allowance. So whenever during the solidification, some process will be takes place, like it will be shrink or it may be expand, it may be contract. So all these things can be compensated by means of these allowances. So as a result, a pattern is made slightly larger to compensate. Pattern allowances refers to these minor changes in the pattern. There are different types of allowances are there. Like 5 types of allowances are there, like shrinkage allowance, draft allowance, wrapping allowance, distortion allowance, and machining allowance. So this is the shrinkage allowance. So whenever if you pour the molten metal, if you want to create a shot put throw ball of 100 mm diameter, suppose if you prepare a metal pattern of exactly 100 mm, then if you use that 100 mm metal pattern in the mold, it will create exactly 100 mm mold cavity. So if you pour the molten metal into this 100 mm diameter mold cavity, then during the contraction property of the shrinkage property of the metal, finally after solidification, you are going to get maybe 98 or 99 or 97 mm diameter of the ball. So it will become a defect component. So instead of that one, in order to compensate the shrinkage, if you prepare a wooden pattern or metal pattern of more than 100 mm, that is the 102 mm or 103 mm or 105 mm, depending upon the material. and shrinkage property of the material. Based on that one, we are going to provide the shrinkage allowance for a particular metal or wooden. So like that, if you prepare or you are going to provide some extra allowances in order to compensate the shrinkage during the casting process. So such type of allowance is known as a shrinkage allowance. And here there are three types of shrinkage allowances are there: liquid shrinkage, solid shrinkage, solidification shrinkage, and solid shrinkage. So liquid shrinkage means here the volume of the metal will be reduced or the contraction that occurs within the liquid state only. Means if you pour the metal of 1500 degrees centigrade or 1700 degrees centigrade of the molten metal, then the temperature after some time, if you give some time for the solidification, then automatically the temperature will be reduced from so within the liquid, the temperature will be reduces and the volume of the metal will also reduce. Such type of shrinkage is called liquid shrinkage. Solidification shrinkage. The contraction as a result of cooling of the liquid to solid temperature is also known as a solidifying contraction. Means here it is going to convert the liquid into a solid by losing the temperature. So that type of shrinkage is called solidification shrinkage. Then solid shrinkage. Once the entire the liquid is converted into a solid, still it is having temperature is more than the room temperature. So in that condition, what will happen if you give some more time for the solidification? Automatically, the temperature of the solid will be reduced from higher temperature to the room temperature. In that condition, also some contraction will be takes place or shrinkage will be takes place. That type of shrinkage is called solid shrinkage. Then draft allowance, and these draft allowances are mainly provided on external or internal surface of the pattern for easy withdrawal of the components from the mold. Easy withdrawal of the pattern from the mold. And it is nearly varies in between 1 to 2 degrees. These draft allowances are changes made to the pattern surface to protect from the damage. So while removing, suppose if you exactly rectangular shape, while removing this pattern from this mold, the mold damages will come into the picture. So in order to avoid this mold walls damage, we're going to provide these allowances or extra taper on this rectangular shape. And after that, we're by pouring the molten metal into this cavity, we're going to prepare these components. After that, we're going to remove the excess material. Finally, we're going to get the exact components. Now coming to the wrapping allowance. This wrapping allowance is also called as a shaking allowance. When comparison to the other allowances, all allowances are positive allowances. And this wrapping allowance or shaking allowance is a negative allowance. Because in the remaining allowances like shrinkage allowance, machining allowance, draft allowance, and all these allowances, by the application of these allowances, the size of the component will be, size of the dimensions of the component will be increases. But by the application of this shake allowance or wrapping allowance, the size of the pattern will be reduced, slightly reduced. So that's why it is called as a wrapping allowance or shaking allowance. So after keeping the shaping or wrapping allowance refers to the change in the pattern dimensions. So the patterns are made slightly smaller than the casting to compensate for the increased castings. So in case of this, I already told you, wrapping or shaking allowance is a negative allowance. By the application of this allowance on this size of the component, size of the pattern size will be reduced. And while removing this pattern from the mold, we are going to wrap or shake the mold pattern. So while wrapping or shaking this pattern, automatically some gap will be formed in between the mold pattern and mold walls. So that itself become as a allowance. It will increase the size of the mold cavity. So with that one, we are going to get the exact size of the components after mold solidification. Now coming to the distortion allowance, and this distortion allowances is mainly provided on components, uneven components. Okay, like a U-shaped and V-shaped components. Instead of preparing exactly V-shaped components, if you bend some more inside or outside during the solidification, some contraction or expansion will be compensated. Like that, we're going to provide some distortion on the pattern. By me, these allowance is called as a distortion allowances. And then machining allowances. So whatever the components are preparing by this sand casting process, those components are not going to get very good surface finish because we are going to working with the sand. Sand is a rough particles. So finally, we are going to get the rough surface components from the sand casting process. So for that one, after removing these metal mold components from the sand molding process, the surface seems to be rough. In order to remove those rough surface, secondary operations is to be carried out like a broaching, honing, or lapping, lustering, all this process. So while applying this process, it is going to remove either 0.5 mm of material or 1 mm of material we're going to remove. So in order to compensate these machining, we're going to provide some extra allowances on those patterns. So such like this, the size of the component will be increased in the machining allowance also.